Okay, ladies and gentlemen, for math today, you'll need your math notebook, math workbook, and a pencil. Don't forget that when I give directions, all you have to do is pause the presentation, follow the directions, and then come back to the presentation. Please write the name of this lesson in your math notebook. Lesson 2-2, thousands to thousandths. Underneath the name of this lesson, write the learning target. The learning target is, I will be able to read, write, and model whole and decimal numbers. In the first lesson, we looked at the place value chart. We're going to go back to the place value chart for a quick review because we'll use the place value chart for our focus of reading and writing decimal numbers in this lesson. Remember, the row of place value names is symmetrical around the ones place. So here's the ones place, and if we work our way out of the ones place in either direction, we have tens and tenths. Those words go together. 2 places out from the ones, we have hundreds and hundredths. And then 3 places, we have thousands and thousandths. So the numbers, as they go out from the ones place in either direction, the place values actually go together. Take a minute and remember back why there isn't a oneths place. There is no oneths place because the places can be written as fractions over 1 for whole numbers, and 1 over 1 is actually the same thing as 1. There is no oneths place. Did you happen to notice any patterns as we were looking at the place value chart? For example, starting at the ones place, what happens as the place values become greater to the left? And what happens as the place values become lesser to the right? The value of each place is 10 times as great as the place value to the right and 1/10 as big as the place to the left. That means that as you get bigger on the place value chart, you would multiply the places by 10. As you get smaller, you would divide by 10 or multiply by 1/10, which is the same thing. Another way to think of it is that moving one place to the left multiplies the place value by 10. Moving one place to the right divides the place value by 10. Reminders for reading and writing decimal numbers. Make sure you are reading the numbers correctly. For example, if you say 437, which we typically say incorrectly all the time, you are actually saying this number, 400 and, with the decimal, 37, not 437, 437. Also, clearly state the THS on the ends of the numbers you read to be clear. So the main focus of this lesson, 2-2, is that numbers can be represented in different ways. Here we have the number 35,026. When we just have the numbers written with digits, we call that the standard form of a number because that's typically how we write it. That's the standard way. There are 4 total ways to name this number. The first is the standard form that we just looked at. Next, we'll look at word form, expanded form powers of 10, and expanded form. We've really already looked at word form because we focused in the first lesson on how to read the number. If you know how to read the number, you simply write that in words, and that is word form. Here we have that same number in standard form. If we write what we are reading, 35,026, we have the word form. Expanded form powers of 10 is the next way that we'll focus on. Here's the number in standard form. To write this number in expanded form powers of 10, you'll multiply the digits by the place they're sitting in. You don't actually solve it. You just show that you would multiply the digit by the place it is sitting in and add that to all of the other digits multiplied by the place they're sitting in. The first digit that we have is 3. 3 is sitting in the 10,000ths place, so we would multiply 3 times 10,000. After that, we have 5. 5 is sitting in the thousands place, so we add to the first expression 5 times 1,000. After that, we have 0. It is not necessary to show the expanded notation of a 0 placeholder. So we skip the 0 and move on to the 2. 2 is sitting in the tens place, so we add to the other two expressions 2 times 10. Finally, we have the last digit, which is 6. So we add to the previous three expressions 6 times 1 for the ones place. If we were to multiply all of these expressions out and then add them together, we would end up back at the standard form of the number, which is 35,026 written in number form. The last method is expanded form, not using powers of 10. So that just means adding the value of the digits in each place. If you start with expanded form powers of 10, but you write the products, you will have expanded form. So on the last slide, we showed the number 35,026 in expanded form powers of 10, written like this. 3 times 10,000 plus 5 times 1,000 plus 2 times 10 plus 6 times 1. To write the number in expanded form, you actually multiply these expressions and get the answer, but you leave them as a sum of the individual numbers. 3 times 10,000 is 30,000. 5 times 1,000 is 5,000. 2 times 10 is 20, and 6 times 1 is 6. In expanded form, 35,026 is written as 30,000 plus 5,000 plus 20 plus 6. Again, it is not necessary to write 0 for the placeholder. So some more notes. I just said it's not necessary to write the expression for 0 placeholders. When the operations are performed, the expanded form and expanded form powers of 10 equal the original number. The power of 10 has the same number of zeros as the term in the expanded form, and the power of 10 used for the expression is the same as the digit's place value.